So this is the question which I was talking about. Here we'll use the relation which we tried to derive in that last video. So I'll write that formula here. So we calculated the phi value there, which was n2 minus n1 by r. That was the value which we got in the last video. Now we'll apply this formula and to solve this type of question. Okay, this question can be solved by using the formula, okay, the reflection through curved surface. But I think that method is bit lengthy, so I'll try to solve this question by using this formula and it will be very short. Okay, so let's see this question. So there's a convex lens, you can see, which has air on one side, water on the other side. So we want to calculate the focal length. So first of all, as you all know, the focal length n by f is equal to constant, right? So so basically they're directly proportional to each other. So basically the focal length depends upon medium. Okay, the higher the refractive index, more will be the focal length. Okay, so here one side we have a medium air, one side we have a medium water. So in both the mediums, water and air, the focal length of the lens, okay, will be different. Okay, here in this question we want to calculate the focal length in water, because the rays are coming from air. So after refraction they will pass through the focus, yes or no? So this focus is in water medium, so we'll try to calculate the focal length in water medium. So let's focus on this one. So first of all, in this one we have two surfaces, two refracting surfaces. This is one, this is two. So here we'll calculate the rays are parallel to principal axis. So phi for the first refracting surface. Now for this one is equal to 1. Here we have 3 by 2, here we have 4 by 3. Okay, this is 4 by 3. Okay, there's a mistake here in this question, so it is 4 by 3 only. Okay, so now the phi value for the first refracting surface. So if we apply the formula phi1 equal to, so it is 3 by 2 minus 1 divided by r. So it is coming as 1 by 2r. Okay, now what is phi2 then? So phi2 will be coming as anyway, instead of calculating phi1 value, okay, I'll just try to get the phi value, okay, in terms of the variables. So n2 minus n1 upon r, I'm writing this one. This is my n1, this is my n2, and this is my n3. Okay, what is phi2 now? For phi2, the ray is going from this medium to this medium, so we can apply this formula here. So this time our n2 will be n3, n1 will be n2. As you all know that how do we take n1 and n2. So it is n3 minus n2, and this time the radius will be negative. So phi2 I can write as n2 minus n3 upon r. Now to calculate the total phi for this combination with the two surfaces are joined together, so phi will be equal to phi1 plus phi2. So from these two equations, when we'll solve this one, we'll get this relation 2n2 minus n1 minus n3 upon r. Okay, I try to solve this relation, okay, try to get this relation just to, in case if you don't know, if you don't want to write these steps, so you can remember this formula directly. So every time when you have this kind of question, you can remember this formula for the convergent lens, okay, and directly you can apply this formula. So phi value is equal to 2 into, what is n2 here? That refractive index of the glass, 3 by 2 minus 4 by 3 minus 1. Okay, it could be minus 1 minus 4 by 3 anyway, and divided by r. R is equal to 30 centimeter. Now if we solve this one, so 3 minus 2 minus 4 by 3, 6 2 by 3, we are getting numerator 13 denominator. So we are getting here 1 by 45. Clear? Now phi value is 1 by 45. Now to find the focal length, so we'll use this formula which we saw in the last video. So phi is equal to n1 by f1 is equal to n2 by f2, like that. Okay, we want to calculate the focal length in water medium. So let's take the focal length is fw, and the refractive index is n3, or otherwise we'll take f3 only. Okay, 3 like that. So what is n3 now? n3 from this relation we can write as, f3 we can write as n3 divided by phi. This phi will be constant. Okay, I hope you understood this relation. Now n3 is the focal, the refractive index of that medium, 4 by 3 divided by 1 by 45. So from here we get a relation and it's coming as the focal length in the water medium 60 centimeter, and that is the answer. So with this approach you can solve these type of questions very quickly. Okay, whatever lens is there, whatever refractant indexes are there, you can solve these questions very quickly just by using this relation phi1 and phi2 and just this relation. That's it. So I hope you understood this question. Thank you.